And we are back. Welcome. We're going to continue to talk about division with remainders. We're going to talk about how we can write them. We're going to talk about what they are, blah, 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 all that other stuff. Today, we are going to be using partial quotients to solve because I do think as we get higher, as our numbers get larger, right, that loop and group or skip counting idea doesn't work just as well. And partial quotient really does lend itself to really understanding the parts, hence partial, that we can see that we fill, and then what happens when we have something left over. So again, we'll talk about that. Remember, this is the answer to a division problem. So let's dive into that process, as always, just by doing some work and looking at it. So division with remainders, thinking about what we do when someone comes along and says to us, hey, you, what if I had 84 and I wanted you to divide that by 5? I don't know. Okay. So knowing that, now we kind of start to think about, all right, well, if we're going to solve this problem, first we're going to set up that partial quotient. So again, that means that 84, and then I have this graphic organizer that some people call a big 7. Okay, whatever. And again, remember what we're thinking about is like, how many groups of 5 can we make with the number 84, right? How many groups of 5 can we make? So I always like with this technique, since the number's bigger, I start thinking about facts that I know to help me solve facts that I might need to know. What? Sorry, I don't know. I don't even know what else I'm out there. So 5 times 1 is 5, right? 5. So if I know 5 times 1 is 5, then I know 5 times 10 is 50. If I know 5 times 2 is 10, then I know that 5 times 20 is 100. And so what that is, again, this is helping me think about how many groups I want to start with. And so noticing here, what I'm going to do is I'm going to make a group of 10 first, right? I'm going to use 5, make a group of 10 that equals 50. So far I've used 50 of my 84, so I have 34 left. Okay, so let's see here. I know that 5 times 5, that's 25. So again, I'm going to take that away. Again, I'm going to go pretty quick through the partial quotient. There are other videos that show this process. So if you're watching this and you're like, wait, what? I'd recommend you go back and watch the partial quotient videos so this makes sense to you. I am now going to regroup. It leaves me with 9. 5 times 2 is equal to 10. That won't work. Can't do that. So I guess it's just 5 times 1 is 5. And I have 4 left over. Now, this is where it's really helpful. This is where I like partial quotients with using remainders. So for starters, let's think of how many full groups we can make. Well, we can make 16 full groups. And then when we think again about this remainder, our remainder is what's down here. And we know it's our remainder when it's smaller than the number we're dividing by. That's one thing to always check. Like if you're subtracting and you look and you're like, oh, I have 10 left over, but I'm dividing by 5. Well, you know you can make more groups. That's actually how that works. So again, remember, now that I have a remainder of 4, what we're really looking at is I have a remainder of 4, but I'm making groups of 5. So I actually have 4 out of 5 left over. So that's where we have this mixed number as our remainder. This actually 84 divided by 5 equals 16 wholes, right? 16 whole parts, or I don't know what I want to say there, boxes, groups, whatever, and 4 out of 5 is left over. Okay, so let's explore that some more, and I'm going to try to model this. This is where like the size of the screen might be a challenge, but I'm going to try to model this so that you can actually see again what we mean by all of that. So I'm going to take I'm going to bring the number down so that I can model it better. Let's take 28 and let's divide that by 6. Okay. All right, so here it is. I'm gonna like walk again through how we saw this and then really what I mean by this remainder being written as a fraction and why this is a fraction. Remember, this states here, if this was to be written as a fraction, this says 28 out of 6 or 28 divided by 6. I mean, that's really what this line means. Right? This is where, again, we're like, oh, wait, division and fractions, they're actually really close. They're very compatible. So that's one thing to keep in mind. This is actually 28 over 6. So this is a top-heavy fraction. 28 divided by 6 is actually a top-heavy fraction. It's 28 being divided into 6 groups. Okay. So let's start with our graphic organizer. Okay, and then we can think about our groups of 6 that might help us. So I know 6 times 1 equals 6. So 6 times 6, 6 times 10 is 60. That's too much. So I guess I'll just start with like that. Okay, I'll kind of stop there. So now let's think about these groups. So what I'm going to do is I'm going to start thinking about, again, a whole. But we know we're dividing this whole into 6s. Okay, so again, I'm trying to draw a model so we can see what this remainder means. So here would be one whole. Okay, so let's play that game. Let's do that simple. What if I did one group of 6? That would equal 6. I would have 22 left over. And 1, 2, 3, 4, 5, 6. There's one group of 6. Okay, now I'm going to do more. I just wanted you to see that, but I'm going to go a little bit higher. So let's see. 6 times 3 is 18. So that's going to leave me with 4 left over. So I just did 3 wholes. So 3 groups of 6. 1, 2, 3. And I got to make these 6s. Okay, and so here's one group of 6. Here's 2 groups of 6, and here's the third group of 6, which, as we can see at this point, right? We see at this point, that's 4 whole groups. And if we can see over here, I have 1, 2, 3, 4 whole groups. Okay, now I know I've done as many whole groups as I can. I know that this is my remainder because it's smaller. And I know, again, as a fraction, what that means is we still have enough to make another group, but we don't have enough to fill that group. So it's cut into 6 pieces because that's what we're doing. We're dividing by 6, but I have 4 pieces left over. So 1, 2, 3, 4. And we all know that if we looked at this as a fraction, this says 4 out of 6. And we all know that these are wholes. So 1, 2, 3, 4 wholes and 4 out of 6. So that's where I'm really trying to relate like this division and these fractions and these mixed numbers and these top heavies about how they actually all relate. We talked about this in the last unit. We talked about fractions in this way. So now it's one of those things where earlier we're like, oh, if you can multiply, you can divide. And now it's like, oh, if you can divide, you're actually really being able to understand and play with fractions. So it helps alleviate the stress that comes with these words in math. Okay, so 28 divided by 6 equals 4 and 4, 6. It equals 4 whole groups with 4 out of 6 left over. 4 whole groups of 6. Okay, all right, which if we did the inverse, 4 and 4, 6 times 6 would actually equal 28. That's pretty cool. So let's do another one. I'm going to try to do that. What I'm going to do, let's see. I got to check the time. I'm going to go ahead and do another one modeling. And then next video, we'll kind of get out of the modeling aspect, I guess. Not that I really want you to, but anyway, moving on. Okay, so let's see. Let's do another one. I should really always have these planned out. I don't know why I was trying to make them up on the spot because it takes time. Let's take 31 and divide that by 6, 7, 7. Let's divide it by 7. Sorry, I had to like think what I was doing. Even though that's going to be hard to model, but I don't care. I like a little challenge. Okay, so 31 divided by 7. So again, if we're using partial products, we're going to have 31 being divided by 7. Now, also remember that this as a fraction says 31 divided by 7 or 31 over 7. So that's also our fraction. A fraction is a division problem. So 7 divided by 31. So what we're doing is we're going to make groups of 7. So I'm actually going to model over here. So I'm going to make one group first. So I have it 1, 2, 3, 4, 5, 6 pieces, or 6 lines make 7 pieces. Okay. What do we know? 7 times 3 equals 21. So I need 3 of these whole groups first. I just did that. So 1, 2, 3, 4, 5, 6. And let's make another one. 1, 2, 3, 4, 5, 6. So those are sevenths. Again, you heard me counting to 6, but they're sevenths. So we just did 3 whole groups. So we're going to fill in all 3 whole groups, which equals 21, which is true. There's 7 pieces. There's 14 pieces. There's 21 pieces, which is also 3 whole groups of 7. Let's see, we have 10 left over. And I'm making so I could do 1 times 7 is 7. That gives me 3 left over. So I just did another whole group of 7. 1, 2, 3, 4, 5, 6, and then fill that in, which would be technically 28 pieces. And then we have our remainder. Again, we know it's our remainder because it's smaller than the number we're dividing by. And that also makes sense because here is 4 whole groups, right? 1, 2, 3, 4 whole groups. That equaled 21 pieces if we counted each of the little pieces. Those 28 pieces subtracted from the 31 we started with leaves us with 3. That's the same thing as the remainder. Oh my gosh, this is amazing. And then again, the remainder isn't just our something, it's leftover. It's 3 leftover pieces when we need to fill 7. So again, that would say like, oh, maybe I'm putting 1, 2, 3, 4, 5, 6. Maybe I'm putting cookies into a box and a box holds 7 cookies. I have 3 cookies left over, so I'm not going to throw them away. I'm going to put them in this box. And again, here's our fraction. We have 3 with a remainder of 3 out of 7, or 4 3/7. Huh, this is so cool. I actually think this is so awesome. I don't know, it excites me. So this is what we're doing here. This is that whole idea of like how it is that we divide. This is how we get remainders. This is what a remainder really means. We can write them as fractions. What we're going to start exploring next-ish in a couple of videos is how we interpret that like in a story problem, right? Like if it was something like, oh, you had 31 kids and you're going to put 7 on a bus, how many buses do you need? Well, you're not going to say, oh, I need 3/7 of a bus. That doesn't make sense, right? Or there's 31 kids and there's 7 buses. How many kids go on each bus? Well, you're not going to be like, oh, well, 4 kids go on a bus and then 3/7 of another kid. Like, no, that doesn't work. You can't take 3/7 of a person. That's, yeah, that's horrible. Don't do that. No. So we'll talk later, like, what does that mean then? What do we start thinking about? So here's numerically how we can write fractions as remainders. And later we'll kind of talk about what do these remainders mean. So as always, thank you. You're awesome. You're wonderful. You are the best. And we will see you next time around.